So this video is going to cover batteries and circuit diagrams, which is in chapter 27-3 of the textbook. Okay, so first off, what exactly is a battery? Well, a battery is a pile of chemical cells, and it maintains a potential difference by a chemical reaction. So these are reduction-oxidation reactions, and they actually maintain a potential difference. So in an ideal battery, you get a constant potential difference maintained between the two terminals, and this is called the terminal potential or the terminal voltage, and we'll use a script E to stand for the terminal voltage. So what happens then, so if you connect some wires or some other circuit element to the two terminals of your battery, it causes a charge, electrons, to move between the terminals. So this is a table from your book. So depending on the type of electrodes you have, it'll actually determine what the terminal potential actually is. So like zinc carbon, so these are your common alkaline batteries, are 1.5 volts, and like lead dioxide, so these are your car batteries. Those are actually multiple cells, but for a total voltage terminal potential of 12 volts. Okay, so in order to draw circuits, we're going to use a standard set of symbols. So there's actually a pretty nice little table listed on Wikipedia if you look up electronic symbols. And these are sort of simplifications of what these things look like in real life. So, and just to make things look nice and neat, wires are always straight lines. And typically you use right angles to make things just a little bit more neat and legible. And here's some of the symbols we're going to use. So here you see, so this is the symbol for a battery. So technically speaking, the one on the left is a single cell battery, the one on the right is a multi-cell battery. Usually we just draw things as single cell, whether they're actually single or multi-cell. So there's a long and a short line. The long line is the positive terminal, the one at higher potential. So here we have the simplest switch you can have, a single pole, single throw switch. And here there's actually several different symbols for a capacitor. So the typical one is you just have two straight parallel lines for a parallel plate capacitor. Some capacitors are actually polarized, so it matters which is the positive and negative terminal. So then you usually have one of the lines is curved, and you can also have variable capacitors. And just to kind of see how this works, so for example, let's say you take a battery, hook up some wires to a switch. So on the left is actually what it would really look like, but then the circuit diagram is actually on the right. So the battery, which is the long line and the short line, the wires are all straight with 90-degree angles, and then we have the open switch. Okay, so let's say we take a capacitor then and hook it up to a battery. So here's our circuit diagram on the bottom. So we've got a battery, some wires attached to a capacitor, and with a switch. So let's say we close the switch. So closing the switch completes the circuit, so charge is going to flow. And what will happen, of course, there's this gap of air insulator between the capacitor plates. So charge is going to build up. So we'll actually get negative charge on one of the capacitor plates, positive charge, or an absence of negative charge, on the other plate. So eventually you're going to reach equilibrium, so no more charge is going to flow when the potential difference across the capacitor matches the terminal potential of the battery. So if you have, say, a 1.5 volt battery, eventually your capacitor is going to charge up until the potential between the plates is 1.5 volts.